So here we are trying to do exploratory data analysis and electrical energy consumption prediction using keras. So the data set that we are going to use is energy consumption data set that we have got from Kaggle, and in this data set you can see we have around 5,000 records. So this is the energy consumption record of 5,000 households, we can say. Month, hour and day of week is given, whether it was a holiday or non-holiday, what was the temperature, humidity, square footage of the house or building, total occupancy, like how many people were there, HVAC usage, whether HVAC usage on or off, and lighting usage, total renewable energy generated, and total energy consumed. So all of these values are given. So first thing is we have simply opened a Google Colab notebook. We are going to use Python pandas to read the data. So import pandas as PD, and this will help us in reading the data. And from here we will simply upload the data for analysis. So once your data set is loaded, just copy the path and load it in DF. So we will simply create the data set. So the file is CSV file. So we will simply load it, and here we will see df.head. So we will get the data set. So this is our data set that you just saw, and all the columns are read properly here. The other libraries that we will need in this project are NumPy as NP, matplotlib.pyplot as PLT, Seaborn as SNS for plotting, and we will also import warnings. Now, just for the sake of this project, we will simply ignore the warnings. Whenever you are doing exploratory data analysis, it is always good to know how many available and missing columns do we have, how many available and missing values do we have in each column. So here we can see that we have total of 5,000 entries in each row, and when you will see the data set, so in every column we have 5,000 non-null values. Data type of month, hour is integer, day of week and holiday is object, which is like a string. Temperature, humidity and square footage of the home are given in float 64. Occupancy is an integer value. The HVAC usage is given as an object. Lighting usage an object. Renewable energy and energy consumption are both float values, and all the columns have non-missing values, so we don't need to fill the missing values here. While doing exploratory data analysis, use df.describe to describe your data set. So for every numerical value that you have, for example, all the int and float values, you will see their count, you will see their average, you will see data like this. So for month, the mean of month, standard deviation, R, temperature. So we can see that the average temperature as per the data set is 24.94 and standard deviation is 3.04. So there is not much deviation here. Most of the values are pretty close to each other in terms of temperature. In humidity, we do have higher standard deviation, and the average humidity value that we have is 44.47. Average occupancy of people is 4.5, and renewable energy generated on an average is 15.20, and total energy consumption is 76.74 on an average. So here you can see, and with the help of first quartile, second quartile, third quartile, minimum and maximum, you will be able to see the distribution of data. We will start analyzing different type of variables also here to see how they are provided in the data set. First, we will calculate the monthly average consumption. For monthly average consumption, we can see we have month here. So in month, minimum is 1 and maximum is 12. Obviously, starting from 1 to 12 months. And here, when you will simply group by month and try to find out the average of energy consumption. So first we will write group by function, use group by function to group the data by month. Then in that df, we are going to select the energy consumption column. In energy consumption column, we will use the mean function to find its mean, and we will reset the index. If you will just do this much, so you will see your monthly average consumption is like this. Okay, here you have month and energy consumption. If you will simply use reset index here, so it will reset your index and you will have the month and energy consumption as columns. This will help us in plotting graphs and seeing monthly average consumption by month. If you remember, we have imported Seaborn as SNS. For this type of data, we can use a bar plot or a column plot. So in Seaborn, there is a bar plot. In the bar plot, we have to provide on x-axis what column do you want to put, on y-axis what column do you want to put. So we have two columns, 12 values as rows. So we will just use x-axis as month, y-axis as energy consumption, and our data is monthly average conversion here. And the palette that we are going to use, it is the color palette. You can use any other color palette here, and we are going to prepare the block. So let's see what's the issue here. So the problem is we did reset index, but we did not save it here. So we just have to save it also. So write monthly index is equal to monthly index dot reset index, and then plot this graph. So here you can see, we can see around 7th month the value is higher as compared to other months. Obviously without title and without, we do have month and energy consumption here, but we can customize the titles. So we will write plt.title. So import matplotlib.pyplot as plt. So plt.title average energy consumption by month, we'll use font size as 16. On X label 14 font size, Y label energy consumption font size 14, and in X ticks from range 0 to 12 we will put the 12 labels, obviously January, February, March up to December, and then we'll use the plt.show function to show the graph. Now you have the values Jan, Feb, March. Instead of 1, 2, 3, you now have the ticker values. We can say around April or July the energy consumption bars are equally high, and as I said, because the standard deviation value is very low as compared to mean, so there is not much of difference here in all months, but still highest bar is at around July and April as per the data set. Now as we calculated monthly average consumption here, average energy consumption by month, we are also trying to find monthly average consumption. We will create a line chart. Figure size will be 10, 6. So plt.figure, plt.plot. In plt.plot, you have to provide x and y. So our x is going to be the month column, and y is going to be the energy consumption column. So just like this, we can select x and y. Marker, we are going to use 0. Color, we are going to use blue, and we will label it as energy consumption. Again, in the title, month average of energy consumption. So here we are just showing how we can use line plot, because plt.plot is a line plot to see the monthly average consumption. So here you can see the monthly average consumption in the month of July. The monthly average consumption is low in case of in the data set. Sorry, in the month of June, I mean. And you can visualize this data set to understand the monthly average consumption. Here you can see, here we have a different value, but it will be more clear. Average energy consumption by month, it will be more clear from the line chart, because here data is starting from around 74 mark. So that's why this is looking like a big difference. So what are the insights from this? Let's add a text column here. So insights are simple. The average energy consumption values remain relatively stable throughout the year, ranging from 75 to 79 across the months. This suggests that energy consumption does not significantly vary based on the month alone. As a result, creating dummy variable of the month column might not contribute much predictive value to the model. Instead, we could consider the following approaches. Okay, and the approaches are: drop the month column entirely to simplify the model, one, or introduce a new season column to capture potential seasonal patterns by grouping month with similar characteristics. This approach preserves insight into how energy consumption might vary by season without adding unnecessary complexity. So we can provide a column like winter, rainy season, summer season, those type of values. So let's do that. So here we are using a function. So we'll write a function called get season. In get season function we will write month. If month is in 3, 4 and 5, we will call it summer. Return summer. So we are kind of creating a calculated column here. Else if month in 6, 7, 8, then June, July, August, monsoon. Month in 9, 10, 11, autumn. Month in otherwise month will be winter. And here we are creating df season is equal to df month dot apply get season. Okay. So in the month we will apply this function and we will drop the month column from original data set, and we will create a column which will be the new column season plus column for column in df column is not equal to season. Basically, with the help of this code, in we will create a season column, and if month is 3, 4, 5, 6, 7, 8, so it will simply write that conditional value when you will see. So now you can see season, winter, summer and monsoon. What we can do, we can write df dot season and see how many values are there for each seasons. So this will be clear. So you can see for winter we have 1400 values, summer 1200, monsoon 1200 and autumn 1200. So the data, because it's a synthesized data, so it very much created just for analysis purpose. But if you'll get the actual data, this value will differ vastly. Now as we created the line chart here, in our line chart we used group by month. We will simply group by season. So now we will have four values. So season average consumption will be df dot group by season. Select the column energy consumption, use mean and reset the index which I showed you. Season order will be summer, monsoon, autumn, winter. We have ordered the season, and season average consumption season. We are selecting the column. So and using pandas categorical method, we will uh, arrange it in season order, and ordered will be true, and season average consumption will be sorted values on the basis of season. Okay, then we will create the line chart so that the data is in same order, and with plt.plot we will pick x and y. So here season and energy consumption will be our x and y values. When you will plot this, it will give you a simple output like this. So you can see as per this data set also, obviously there is not much of difference, but we can see in monsoon season the average energy consumption is lower than others. It is highest in case of winter, and in case of summer, then in case of summer, then autumn, and then monsoon. So you can see the order in which the energy average energy consumption is higher than others. As we have calculated the values by season here, now the next column that we have to analyze is hour of the day, like at which hour of the day the average consumption is highest. Okay, so here in hour of the day, our average consumption, we are just going to use df dot group by r. Okay, using mean and reset index as we did earlier, and then we will use line plot. R in line plot, X will be your R, Y will be energy consumption, marker O, line style we are using dashed, and color B. You can use any other color. You can use R or G, whatever color you prefer. And then title, your X label, Y label, and your ticks, that is from 0 to 24 because there are 24 hours. Okay, here also remember when we created, so here we did not use ticks, but here we are going to use ticks like from 0 to 23. And plt.grid we are using, so we'll display it in a grid, looks nicer. And here you can see average energy consumption by hour of the day, and we can see maximum is at 1 a.m. and minimum is at 5 a.m. So looks like when people are going to sleep, mostly in this data set, most people are going to sleep late night. So at that time we have the maximum value. So here also, because the average consumption value is between 75.5 to 78.8, so we can see some difference here. But here also the values are not very much clear. So we'll just introduce a text here. What are our final predictions from here? So predictions are like this. Although there are some variations in energy consumption throughout the day, the values remains within a narrow range, again 75 to 79. This indicates that energy consumption does not significantly differ by individual hour. There is not too much difference. So to simplify the model, while still capturing time of day effect, we can group the data into hours and make it into a broader time period with similar energy consumption pattern. So we will say from 6 a.m. to 12 p.m. is morning, 12 p.m. to 6 p.m. is afternoon, evening is 6 p.m. to 9 p.m. and night is 9 p.m. to 6 a.m. So this approach reduces the number of features, lowers the model's complexity that we are going to use for prediction using keras, and retains valuable insight into how energy consumption varies across different parts of the day. So we will do the similar thing as we did for season, uh, as we created 4 different season values. So we are going to create 4 different values here also. Remember, uh, there we simply change the values into seasons like this. We created a function, and now similarly we are going to do that. And we have created a function called get time of the day r. If r is between 4 and 12, return morning, 12 and 16 return afternoon, 16:21 evening, else night. We are creating a new column, time of day, which will be from r apply get time of the day. So this way you can apply a function on your column, and this will create this column. You will have all the values, and we will drop r. If you want to keep, you can keep, but we will simply drop it because we don't need it anymore. And we are creating 2 columns, season, time of the day, plus column for column in df columns if column not in season or time of the day. This way, this is a simple way of adding a new column from your different calculated conditions. This is like different cases. Case when, return this, case one, return this, and then you will get the value. Now when you will write df dot head, or you will see df, you will see that similarly you also have a time of the day. Okay, and based on your time of day also, you can see how many values do we have. So like df dot time of the day dot value underscore counts dot plot kind is equal to pi. Auto pct is equal to percentage point to float. So let's see again. I don't know why I am writing this incorrectly. So here you can see 34% of the values that we have are morning values, 16.32 afternoon, 20% evening, and 28% night values. So this is a simple way to count values and plot them in terms of percentage. So as per our original variables that we had and its effect on energy consumption, we recreated month, recreated hour. Now let's see day of week. Will that make any difference? So for day of week, we will again use group by energy consumption, reset index. We will set the order Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and day of week average conversion. We'll use the pd.categorical, and in categories, day of week order, we'll use this order, and order is equal to true. Then we will use sort values in day of week terms to sort them, and this will give us figure, and we'll use bar chart here. So in plt.bar, on x-axis day of week will be there, on y-axis average energy consumption will be there, and let's see length of different bars. So you can see obviously here we have very little difference in different days, right? So we can simply drop this column. This column is not of too much use for us, so we'll simply drop this column, and because there is not too much effect on day of week, effect on energy consumption, and we cannot even group them. Yes, we can group them as weekdays or weekends, but again we will simply drop this column. If you want, you can try that way also. Just create two columns. If it is from Monday to Friday, call them weekdays, and Saturday, Sunday, call them weekends. Now our exploratory analysis is there. Obviously, our categorical features are season, time of day, holiday, HVAC usage, yes or no, and lighting usage here. Okay, so these are the values. Lighting usage off or on. So with the help of these values, we will create dummy variables. So because all these values are like a string values, so we will write pd.getDummies. This function will take your data frame as your first argument, and columns will be your categorical features, and drop first is equal to true. We will drop the original values, and then these will be created as dummy variables. You can see here true, false, true, false, true, false. So all these were time of day, evening, false, time of day, morning, false. So this way you will have your dummy variables ready. If you want to learn in great detail what dummy variables and everything what we are discussing, so we also have a dedicated Python pandas playlist, dedicated machine learning playlist, where we have explained these terms. But in order to apply machine learning, we cannot directly apply on these object values, so we have to create dummy variables for them. In your supervised machine learning, you always create your input variables and output variable. So input variables are everything except energy consumption. So we will write df.drop column is equal to energy consumption. So when we will drop the output, everything else will be our input, and y is equal to df.energy consumption. This will be our output variable. So inputs are 2D data frame, y output is a series value for us. Now we will break the data set into train, test, and split. So from sklearn.model selection, we will import train, test, and split. X train, Y test, Y train, Y test. So it will create four variables for us: a training data set with X train and Y train, a testing data set with X test and Y test. Train test split function will randomly select. See, we have 5,000 samples. So we are using 20% of them for test. So 1000 samples will be selected for testing, In 4,000 samples will be selected for training. So model will learn from those 4,000 samples and apply the same logic on those 1,000 samples for prediction purpose. So we will just break it. So just to show you, if you write xtrain.head, you will see all the input values here, okay? And all these values are Boolean values. So just like 0 and 1 here. So xtrain.head you can see, and if you will write xtrain.shape, so you will see the size of it also. So it has 4,000 samples with 14 columns each. So by looking at our features like temperature, humidity, square footage, we can see that they have very different ranges. Season, monsoon, they are 0, 1 type of values, right? So when you have features with very different ranges, so what you have to do, you have to use minimum maximum scalar, okay? And for this is showing us distribution of white range. So in minimum for minimum maximum scalar, use sklearn dot pre-processing minimum maximum scalar. So this will simply scale all of your values together. So we'll create a scalar object from min max scalar class. Then x trained is scaled. We are going to create a scaled version of x trained, scaled version of the features. So a scalar will fit transform x train, and similarly scalar will transform x test. So this will create x test is scaled. So when you will run this, okay, and see, let's see the head of this. So you will see some difference in the value scale. Let's select what is this. So basically this is an n dimensional array here. You can see with scaled values. So on our page itself, we created object image classification project with convolutional neural networks. There we explain the usage of layers and everything in great detail. It's a long video with too much explanation on layers, how they work. So if you want to learn in great detail, you can see that. That's why here we are using TensorFlow, and from TensorFlow we are using keras, and we are importing the sequential model, okay? And from keras we are importing the layers for creating our network. So we will simply first of all import this, may take some time. So here is our explanation for that also. Sequential model meaning that layers will be added one after another in a linear fashion. The output of one layer will be input to the next layer, and it's a simple and common way to build neural networks, okay? So that's what we are doing here. We are creating a sequential model here. In model we are using dense row, okay? 32 activation is equal to ReLU. So here you can see uh, activation, this activation function used here, the rectified linear unit, it outputs the input directly if it is positive or 0 if it is negative, and it introduces non-linearity to help network learn complex pattern. An input shape can be like this 32 32 3 specifies the shape of input image. Here it is input image, in our case it is the input array that we have, okay? So this will simply create our convolutional neural network, and from tensorflow.keras.optimizers we will import RMS property, okay? And from TensorFlow class losses we will import Huber. So this is to compile, with a model will compile optimizer is equal to RMS property, and learning rate is 0.001, loss is equal to Huber, metric is equal to MAE. Everything here is explained in detail in previous chapters also. Now the model is compiled. When you will simply write, sorry, model summary, it will give you detail of layers. So this is layer, like first is dense layer, dropout layer, dense layer, dropout layer. So here you can see understanding of different type of layers. and you will compile the model. Okay, so you will have your layers, and you can understand this in great detail. So you can just understand these are the simple layers for our model. And now we will create the history variable. So we will fit the model with x trained scale and y train, and validation data will be x test scale and y test. So this is a simple way. Epochs is 30 times, batch size will be 32, and it will now start, you know, applying or fitting these values here and learning from it. Epoch is 22, 3, 4, 5, 6, 7, 8, 30. So we can also plot for this loss, May, and value loss. So here we will plot training and validation loss and plot training and validation MAE, which is mean absolute error. So model loss over epochs and mean absolute error. This kind of helps us in understanding these type of elbows around 10. So you can see model MAE over epochs, the mean absolute error. Now after plotting this, we simply evaluate the model. So test loss comma test, MAE will be model dot evaluate x test is scale and y test. Print the test loss and test MAE. Test loss value is 5.7 and test MAE is 6.26. So which is as per the data. Now we will plot a graph between true energy consumption and predicted energy consumption to understand this, like how accurate is the model. So here we are going to create two histograms. First histogram will be between y test and y predicted. Okay, because we have created the y predicted using model.predict function. So using the x test scale that we created earlier. So you can see here the difference between true energy consumption and the predicted energy consumption. This kind of tells us about accuracy of our model. Now to find out the MSE, that is mean squared error, MAE and R square values, we will use sklearn.matrix, import mean absolute error, mean squared error, R2 square or R square score, explained variance score. Import numpy as NP. MAE will be mean absolute error. MSE will be mean squared error using y test and y predicted, y test and y predicted, and root mean square error will be NP dot square root of MSE, which will be calculated. R square will be R2 score between y test and y predicted. Basically, you have test values and predicted values. Okay, so now on the basis of your test values and predicted values, you can visualize this. But if you want to see R square, if you want to see MA, you can do it like this. Okay, R square is 0.29 low, explained variance score is 0.29, and mean squared error is 1.41, and mean absolute error is 6.28. So this kind of explains us the accuracy of our model. Obviously this is a synthetic data set, and this is the way to create a model, and we can, you know save our model to something like model.keras. Obviously this IPyNB notebook was referenced from a Kaggle notebook, and here you can see your model is created. Now you can simply download it, and then we can use the model later for prediction purpose. So this was a simple electrical energy consumption prediction using keras, using neural network. So try this. If you want this IPyNB file, this Jupyter notebook file, please uh, see the description. We will provide a link to download this. Thanks for watching this video. Have a nice day.